concerning Yellowstone supervolcano. A scan exposes huge underground plumbing network only scratched the surface. Airborne scans of ground beneath Yellowstone National Park helped shine a light in the hydrothermal plumbing that supplies its iconic geysers like Old Faithful. And we have a National Park Service video of this. Let's listen to them. We know that Yellowstone supervolcano at the National Park in Wyoming houses over 60% of the world's geysers. So Old Faithful, we know, is one of the best known geysers of the world, and Yellowstone has 60% of the world's geysers and over 10,000 hydrothermal areas. Yellowstone National Park covers 3,500 square miles of the U.S., home to some of the world's most iconic hydrothermal geysers and fumaroles. They include the iridescent colors of the Grand Prismatic Spring, bubbling mud cauldrons that are the artist paint pots, and of course Old Faithful, the magnificent cone geyser that erupts and sprays water and steam roughly every 44 to 125 minutes, and millions of tourists each year marvel over the park's many hydrothermal spectacles. So do earth scientists as they attempt to plumb the underground systems that formed and maintain these geysers. In their study, geophysicist Professor Stephen Holbrook of Virginia Tech and his colleagues conducted special airborne scientific surveys of Yellowstone using a special instrument called SkyTem. It consists of a large loop of wire suspended from a helicopter. The system, which emits repeated electromagnetic signals to the ground, measuring the response of electrically conductive bodies, allows them to identify areas underground with unusual electric and magnetic properties. Professor Holbrook said, the combination of high electrical conductivity and low magnetization is like a fingerprint of hydrothermal activity. It shows up very clearly in the data. The method is essentially a hydrothermal pathway detector, he said, and by making repeated passes over the path, the team were able to probe the subsurface along some 2,500 miles of so-called helicopter lines from which they could create stunning maps of the subsurface plumbing under Yellowstone that supplies geysers such as Old Faithful. Professor Holbrook said one of the unique aspects of this data set is its extensive coverage of this huge system. He said we were able not just to look deep beneath the hydrothermal features, but also to see how adjacent features might be connected in the subsurface across great distances, and that's never been possible before, he said. The research found that, perhaps unsurprisingly, the nature of Yellowstone's hot springs are profoundly influenced by the geology of the vast national park, of course. Hot hydrothermal fluids, comprising both water and dissolved gases and minerals, were found to ascend vertically from depths of more than 0.6 miles, that's over half a mile down, into the park's major hydrothermal fields, traveling along faults and fractures in the rocks. They are complex. They completed this journey, and the fluids mix with the shallower groundwaters that flow both beneath and within the park's lava flow deposits. And according to the team, the findings help to fill a long-standing gap in our understanding of the deep hydrothermal systems that fuels Yellowstone's iconic geysers and fumaroles. Previous studies examined the park's surface hydrothermal features, such as, for example, the eruptive intervals of the geysers, the chemistry and temperature of the mud pots and springs, and the unique bacteria that thrive in these extreme hot environments. Others, meanwhile, have used seismic data to learn about the earthquakes and deeper heat sources below Yellowstone, but little had been known about the exact nature of the connection between these deep fluid sources and their surface features. As Professor Holbrook says, our knowledge of Yellowstone has long had a subsurface gap. It's like a mystery sandwich. We know a lot about the surface features from direct observation and a fair amount about the magnetic and tectonic system several kilometers down from geophysical work, but we don't really know what's in the middle. He said this project has enabled us to fill in those gaps for the first time. One such mystery, the study addressed concerns whether or not different hydrothermal areas of the park, exhibiting different chemistries and temperatures, might be supplied by different deep fluid sources. The team found that the deep structure beneath areas like Norris Geyser Basin and the Lower Geyser Basin is remarkably similar. This suggests that the observed surface differences are actually the result of variable degrees of mixing with shallow groundwater. The paper's author and geophysicist Dr. Carol Finn of the U.S. Geological Survey, USGS, said, "While the airborne data were still being collected, we saw the first images over Old Faithful and knew instantly that our experiment had worked." She said, "We could for the first time image the fluid pathways that had long been speculated." She said, "Our work has sparked considerable interest across the range of disciplines, including biologists looking to link areas of groundwater and gas mixing to regions of extreme microbiological diversity, geologists wanting to estimate volumes of lava flows, and hydrologists interested in modeling flow paths of groundwater and thermal fluid." She says, "With the paper as a guide and the release of the data and models, we will enable research to these diverse scientific communities. The researcher study may be complex, but Yellowstone still holds plenty of mysteries. In future studies, for example, Professor Holbrook said that they would like to look for further evidence for distance connections between isolated groundwater and hydrothermal areas. The Sky Team data," he says, "has already revealed evidence for subsurface linkages between hydrothermal systems in Yellowstone that are up to 6 miles apart." And Professor Holbrook added that might have implications for the coevolution of thermophilic bacteria and archaea. The notion that airborne geophysical data could illuminate something about the life of microscopic organisms living around hot springs is a fascinating idea, he said. The team have also released their geophysical scans, allowing other researchers to conduct their own analysis, delving into the remarkable data set. So Professor Holbrook said, this is so big that we've only scratched the surface with this first paper. I look forward to continuing to work on this data and to seeing what others come up with too, he said. It's going to be a data set that keeps on giving, and the full findings of the study are published in the journal Nature magazine. This is by Express UK, Ian Randall. Please leave your comments, and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.